There are certain pieces of machinery in your house that are just completely invisible to you.
Right, until they aren't.
Exactly. I mean, they're invisible right up until the exact moment they ruin your day. You never, ever think about your water heater. It's just this silent background character.
Oh, yeah, completely ignorable.
Yeah, right up until you step into a freezing cold shower on like a random Tuesday morning, or worse, you walk into your utility room and find yourself standing in a rapidly expanding puddle of water.
It is the absolute classic homeowner trap. I mean, it goes from being a completely ignorable metal cylinder to the absolute center of your universe in, what, a matter of seconds.
Literally a seconds.
And naturally, it only ever seems to happen at the worst possible time, like right before a holiday or, when you have guests staying over.
Oh, always. And when that day comes, you are under the gun. You're panicked, you're shivering, and you just want hot water back immediately.
Which is when people make the worst decisions.
Right. Because if you rush this decision just because you're desperate, making the wrong replacement choice is literally going to cost you twice.
Yeah.
You're going to pay once for the installation, and then you're going to pay all over again, month after month, either through sky-high energy bills or by having to prematurely replace a unit that just, doesn't fit your home's actual architecture.
And that panic buying is exactly what we want to avoid today, because the landscape of this equipment has completely shifted over the last decade.
Right.
I mean, we're in 2026 now, and there are 3 legitimate, totally distinct engineering options on the table.
Yeah.
But, and here's the critical thing to understand up front, there is no universal best choice.
You can't just buy the most expensive one and be done with it.
Exactly. You can't just throw money at it and assume you solve the problem.
Yeah.
It entirely depends on 3 very specific environmental and infrastructure factors about your house.
And that is our mission for this deep dive. We are going to completely demystify the water heater market. We're giving you a shortcut to being a deeply informed homeowner so you can, choose the right equipment for your specific house.
And completely ignore all the shiny marketing hype.
Exactly. We've got some great sources guiding us today. We're looking at data from the energy.gov Energy Saver page, alongside some really grounded advice from an HVAC insider industry piece.
Which is fantastic, by the way.
It is. And we also have this incredibly practical transcript from an Oklahoma-based show called Cool Talk. And looking at all this, it's clear that avoiding the trap comes down to understanding the mechanics of your choices. So let's start with the baseline, option 1.
Right. The traditional tank water heater.
Yeah. The 40 to 50 gallon insulated steel tank. It uses, a gas burner or electric elements inside the tank to hit the water, and it usually just sits in a dark closet or a garage.
The old reliable.
Right. And these are the defaults in this country for a reason.
They are. Yeah, and they're the default primarily because of simplicity. I mean, the engineering is incredibly basic. Which is a good thing, right? It is. It means they work reliably. They're relatively cheap to manufacture, and most importantly, pretty much any professional plumber can swap one out in about 3 hours.
Wow. 3 hours.
Yeah, and that's without fundamentally altering your home. If you're looking at, say, a natural gas-fired 40-gallon tank, fully installed, you're looking at a range of roughly $1,500 to maybe $2,500.
Depending on the brand and stuff.
Exactly. And, how your existing exhaust venting is set up. And standard electric tanks are even a bit cheaper than that.
Okay, so the ideal use case here is pretty straightforward. You have a small household, maybe 1 or 2 people, and you're on a tight budget.
Right.
Your old tank lasted you 12 years, you never ran out of hot water, and honestly, you were perfectly happy with it. You don't want to deal with the headache of upgrading your electrical panel or running new gas lines.
Or cutting holes in your roof for new venting.
Right, you just want a one-day fix so you can go back to completely forgetting about it for another decade.
Precisely. If that is your situation, you just replace the old tank with a new tank and walk away. I mean, it's the path of least resistance.
But I have to push back on the long-term logic here, especially when we look at the energy.gov data.
Okay, let's hear it.
Because when you really break down how a tank works, the underlying premise is, well, it's incredibly wasteful. It's kind of like having a car sitting in your driveway, and you just leave the engine idling 24 hours a day, 7 days a week.
Burning gas, just in case.
Right. Just in case you suddenly need to run to the grocery store. It just doesn't make sense.
That is a highly accurate analogy, actually. You're describing what the industry calls standby loss.
Standby loss, okay?
Yeah. Physics dictates that heat always seeks cold. So even though that steel tank has a layer of foam insulation around it, It's constantly bleeding heat into the surrounding air of your garage or closet.
Right. So you are paying to keep 40 gallons of water piping hot while you're at work, while you're sleeping?
While you're away on a 2-week vacation.
Yeah. You're just fighting a losing battle against ambient room temperature.
Yes. And over the lifespan of the equipment, that standby loss translates into real, measurable money just leaking out of your wallet. You're burning natural gas or pulling electricity from the grid constantly just to maintain a baseline temperature.
For water you aren't actively using.
Exactly.
And beyond the sheer energy waste, there's the ultimate fatal flaw of these tanks. They only last about 10 to 12 years because they hold water constantly. And when they finally give up the ghost...
They fail wet.
Yeah, that's what the HVAC guys call it, right?
That is the industry term, yes. Feeling wet. They don't just quietly stop turning on one day.
Oh, no.
Inside that tank is an anode rod, and it's designed to attract corrosive elements in the water. But once that rod depletes, the water starts attacking the steel tank itself.
And then it's just a matter of time.
Right. Eventually the steel corrodes, it rusts through, and the tank begins to leak.
Which means context is everything. If your water heater is sitting in, an unfinished concrete floor garage next to a floor drain, a leak is an annoyance. You mop it up.
Sure.
But if that tank is sitting in a tight closet right next to your finished basement with brand new carpet, or, worse, on the second floor directly above your kitchen drywall,
Oh, man.
failing wet is a complete disaster. The water damage alone can eclipse the cost of the water heater itself by thousands of dollars.
Which is why the location of your current tank is often the deciding factor in whether you want to move away from this technology entirely.
Exactly. So if paying for constant standby loss and, living with the background anxiety of a catastrophic indoor leak are the glaring flaws of a tank, the engineering solution seems incredibly obvious.
Just don't store the water at all.
Right. Just heat it exactly when you need it. Okay, let's unpack this. Option 2, tankless water heaters.
Tankless units are fascinating from an engineering perspective. They're very compact, usually about the size of a carry-on suitcase.
They mount on the wall, right?
Yeah, wall-mounted, exactly. And they consist of a highly efficient copper or stainless steel heat exchanger. They don't hold any standing water at all.
So how does it know when to heat the water?
Cold groundwater comes into one side, and the unit only fires up when a flow sensor detects movement, meaning you just turn on a hot water tap at the sink or the shower.
Ah, okay.
The water is heated instantly as it passes through that serpentine heat exchanger, and hot water comes out the other side.
Which completely eliminates the standby loss we just talked about. I mean, you are only paying for energy in the exact moments you are demanding hot water.
Entirely. The idling car is officially turned off.
And this is where the HVAC Insider article really leans in. They pitch tankless heavily as a comfort upgrade.
Definitely.
Because it's not just about saving space in your utility room, it's about a fundamental lifestyle shift. Like, if you have a big family, say, teenagers taking 30-minute showers while you're running the dishwasher and maybe trying to fill a large soaking tub.
A traditional 40-gallon tank is going to tap out.
It has a hard mathematical limit, and then you are waiting 20 minutes for that big barrel of cold water to heat back up.
Right.
But with the tankless system, as long as the unit can keep up with the flow rate of the faucets, you have endless hot water. You simply never run out.
And that is a very real, tangible benefit. For a specific type of high-demand household, never having to ration hot water is a massive quality of life improvement.
But here is the million-dollar question.
Okay.
If they give you endless hot water, and they don't waste your money on standby loss, and because they don't hold standing water, they last 20-plus years.
Which is double the lifespan of a tank, yeah.
Right, so why doesn't every single house in the country have one of these mounted on the wall?
Because of the hidden infrastructure costs.
Wow.
The upfront financial reality is a very harsh wake-up call for a lot of homeowners who just, want the endless showers. To get a natural gas tankless water heater installed in a typical home, you're looking at roughly $4,000 to $6,000.
Yeah. Wow, wait, so if I'm upgrading to tankless, I'm not just buying a fancy new water heater. I'm essentially paying to replumb my home's gas infrastructure and rewire my breaker box.
That is exactly what you're doing. No wonder the quotes are coming in at $6,000, right?
Seriously.
Remember the physics of what we're asking this machine to do.
Yeah.
It has to take groundwater that might be, say, 50 degrees, and heat it up to 120 degrees in the roughly 3 seconds it takes for that water to travel through the heat exchanger.
That's incredibly fast.
It is. So to do that, the unit has to fire at an incredibly high BTU rate.
Let's clarify BTUs for a second for everyone. A BTU, or British thermal unit, is roughly the amount of heat you'd get from striking a single wooden kitchen match.
Right.
So a standard tank water heater might use 40,000 matches an hour to slowly warm up that big barrel of water. But a tankless unit,
A tankless unit might need to generate 199,000 of those match strikes instantly.
oh my God.
Just to heat that freezing groundwater on the fly, it needs a massive, explosive amount of energy all at once.
Right.
Because of that, your existing half-inch gas line that was perfectly fine for the slow and steady tank is almost never big enough to feed a tankless unit.
You have to upgrade the pipes.
Yeah, you're paying a plumber to run a larger dedicated 3/4-inch gas line all the way from your gas meter to the unit.
And a bigger fire means different exhaust, I'm assuming?
Precisely. It's burning so much fuel so quickly and extracting so much heat from that exhaust in the process that the resulting exhaust gas is actually relatively cool but highly acidic.
Oh, wow.
So you can't just vent it up the old metal chimney you were using before. You usually have to install entirely new venting, drilling holes, and running new PVC pipes out the side of the house.
That sounds like a major construction project.
It kind of is. Plus, tankless units have complex computer boards and flow sensors to manage that instantaneous heat safely.
So you need an electrician, too.
Exactly. You need an electrician to come in and run a dedicated electrical circuit just to power the brains of the unit.
Okay, so you're coordinating a plumber, a gas fitter, an electrician, and someone to patch your drywall.
Pretty much.
But wait, what if you don't have natural gas at all? What if you live in a house that is 100% electric? Can you just get an electric tankless water heater?
You can, but it is a completely different and usually much worse conversation.
Really? Why?
Heating water instantly with electricity requires an astronomical amount of electrical current. For a whole house electric tankless system, you typically need 3 or 4 dedicated high-amp breakers.
That sounds like a lot of power.
It's massive. For most homes built before recent years, that requires a massive upgrade to your home's main electrical service panel,
Oh, no.
sometimes requiring you to upgrade to a 300 or 400 amp service. The math simply doesn't pencil out. It is prohibitively expensive to upgrade your entire home's connection to the power grid just to run your water heater.
Okay, so synthesizing this, tankless is basically a luxury remodel choice.
That's a good way to put it.
It's fantastic for big families who already have robust natural gas lines, who want the comfort of endless hot water, and who are willing to pay double up front to completely overhaul their utility setup to get it.
Right.
But what about the listener who wants incredible energy efficiency, who hates standby loss, but who does not want to tear open their walls to run new gas lines or drop thousands upgrading an electrical panel?
That leads us to the dark horse of the water heater market.
Here's where it gets really interesting. Option 3, heat pump water heaters. And you'll also see these sold as hybrid water heaters at the hardware store, right?
Yeah, that's right. And this is the technology that most homeowners haven't even considered because it sounds too technical.
Right, heat pump sounds intimidating.
But according to the raw data from energy.gov, it's the option that makes the absolute strongest financial case for a very specific type of home.
Okay, so this is effectively a refrigerator running in reverse,
Yes,
right?
exactly.
Because instead of pulling heat out of an insulated box to keep your groceries cold and dumping that heat into your kitchen, which is why the coils on the back of your fridge are warm, this thing is pulling ambient heat out of your garage and injecting it directly into the water tank.
That is exactly how it works. When you look at one, it just looks like a regular, tall electric water heater. But it has this boxy little unit sitting right on top of it.
Okay.
That box is a small air source heat pump. It uses a fan to pull in the surrounding room air, passes it over evaporator coils filled with refrigerant to extract the heat, compresses that refrigerant to make it even hotter, and then transfers that heat into the water.
And this completely changes the efficiency math because a traditional electric water heater uses electric resistance elements.
Right.
Which are basically giant metal toaster coils submerged in the water, which is incredibly inefficient.
Right. Electric resistance is a 1-to-1 ratio. You pay for 1 unit of electrical energy, and the element generates 1 unit of heat energy.
It's mathematically capped.
Exactly. It is physically impossible to be more than 100% efficient. But a heat pump doesn't actually create heat from scratch.
Right, it just moves it.
It just moves existing heat from one place to another.
So because you aren't paying the electric company to create the heat, you're only paying for the relatively small amount of electricity required to run the fan and the compressor.
Yeah,
The heat itself is entirely free, courtesy of the warm air in your garage.
exactly.
Uh-huh.
And because of that mechanical advantage, the efficiency numbers are staggering. The Energy.gov data shows that these heat pump water heaters are actually 300% to 400% efficient.
400%.
Yeah. They deliver 3 to 4 times more heat energy into the water than the electrical energy they consume to do the work.
That's wild.
Over a standard 10-year lifespan, for a household using a normal amount of hot water, you're looking at saving roughly $1,500 to $2,000 straight off your electric bill.
And the upfront numbers make it really tempting, too, because a heat pump water heater installed is generally in the $2,500 to $4,000 range.
Right.
So you are paying a premium of about $1,000 to $1,500 over a dumb standard electric tank.
Yeah.
But because your monthly electric cost to heat water drops by up to 70%, that premium completely pays for itself in just 3 to 5 years.
Oh, it really does.
After that, you are quite literally just keeping the savings.
It's one of the few home upgrades that has a guaranteed, mathematically proven return on investment in a very short window.
Okay, but hold on. Whenever the numbers look that good, my alarm bells go off.
Fair enough.
I've got to push back on the complexity here because if these heat pumps have fans that pull in dusty air and they have filters that need to be cleaned and compressors and they generate condensation so they need drain lines,
Yeah, there's more to it.
aren't we just trading the beautiful simplicity of a steel tank for a highly complex moving machine? I mean, is it going to require expensive annual maintenance? Does that $1,500 savings actually survive the repair bills when the compressor dies in year 6?
That is a very valid concern. You are introducing moving parts into a system that traditionally had none.
Right.
You do have to rinse the air filter every few months, much like a window AC unit, or the system will choke and the efficiency will plummet.
Okay, so a little bit of upkeep.
But the core refrigeration technology is extremely mature. I mean, it's the exact same reliable tech inside your kitchen fridge that runs for 20 years without you ever servicing it.
Oh, that makes sense.
The real catch with this technology isn't the maintenance. The catch is purely environmental.
Right, because this thing is basically a temperature vampire. It has to suck the heat out of the room it's sitting in to do its job.
What's fascinating here is that because it's a temperature vampire, it has strict spatial rules. The heat pump needs a large volume of warm air to pull from.
How large are we talking?
Well, specifically, the manufacturer guidelines state it needs a space that has at least 1,000 cubic feet of air around it.
Which is roughly, what, a 10 by 12 foot room?
Exactly. And the ambient temperature in that space needs to stay above 50 degrees Fahrenheit year-round to operate efficiently.
So shoving this thing into a tiny, cramped, understair laundry room with the door closed is a terrible idea.
It is a recipe for failure. It will quickly suck all the heat out of that tiny closet, drop the room temperature down to freezing, run out of ambient heat to pull,
And then what happens?
and then its computer will be forced to switch back to those inefficient electric resistance backup elements just to keep your water warm.
So you completely lose the 300% efficiency you paid for.
Exactly.
And what if your water heater currently lives in a conditioned hallway closet right in the middle of your living space?
That is the ultimate robbing Peter to pay Paul trap.
How so?
If you put a heat pump water heater inside the conditioned envelope of your home, it is going to suck the heat out of your hallway and dump a constant stream of cool air-conditioned air right back into your house.
Oh, I see. In the summer, maybe you don't mind a little extra free cooling.
Sure, but in the dead of winter, your home's central furnace is going to have to turn on and burn gas or electricity to replace all the heat that the water heater just stole from the hallway. You aren't actually saving any energy globally. You're just shifting the energy burden from your water heater directly onto your central heating system.
That makes total sense. So looking at the Cool Talk transcript, those guys point out the absolutely perfect, ideal scenario for this technology. An attached, unconditioned garage in a place like Oklahoma or Georgia.
Yes, the southern or midwestern garage is the perfect ecosystem for this. In a moderate to warm climate, that garage stays warm or even brutally hot for 9 months out of the year.
Right.
So the water heater has a massive unlimited supply of free ambient heat to pull from.
And as a byproduct of moving that heat, the exhaust that blows out of the top of the unit is cool, dehumidified air.
Yep.
So it essentially acts as a free, slow-drip air conditioner for your muggy garage in the middle of summer.
Exactly. You get cheap hot water and a more comfortable garage. And the heat it pulls during the winter is coming from a space you weren't paying to heat anyway.
So you aren't fighting your own furnace.
Right. Plus, putting in the garage solves the final hurdle. The noise. Yeah, heat pump water heaters are not silent.
Right, because of the fan and the compressor ticking on.
Yes. They run at about 45 to 55 decibels, which is roughly the hum of a modern refrigerator, maybe a bit louder when it really ramps up.
Okay, I see where this is going.
If that unit is in your hallway, 10 feet from your bedroom door, hearing a compressor kick on at 2 a.m. is going to drive you crazy. But out in the garage, you will never even notice it.
So what does this all mean? We have all three options on the table. We have the cheap but wasteful traditional tank. We have the luxurious, endless, but infrastructure-heavy tankless.
And we have the highly efficient but space-dependent heat pump.
Exactly. Let's build the ultimate decision matrix for the listener. I want you to visualize your own home's layout right now as we walk through this.
It really boils down to an incredibly simple flowchart based on 3 questions. Question number 1. Where does the unit live?
Okay.
If it's in a garage, a large unfinished basement, or a big mechanical room that stays relatively warm, the heat pump water heater is absolutely your prime candidate.
But if it lives in a tight hallway closet inside your heated living space...
The heat pump is off the table.
Got it. Question number 2. Do you have natural gas already running to the house? If yes, and you are willing to pay for the upgraded gas line, tankless is a viable option for endless water.
Right.
But if you do not have natural gas, tankless is almost certainly off the table because whole house electric tankless will require that massive electrical panel upgrade that just ruins your budget.
Spot on. And question number 3. How big is your household, and do you actually run out of hot water right now?
That's a good one.
If you're a family of 2 or 3, and your old 40-gallon tank never once left you shivering in a cold shower, don't over-engineer the solution.
I love that quote from Dave in the Cool Talk transcript. He says, the biggest mistake homeowners make is matching the marketing to their imagination instead of matching the equipment to their actual house.
It's a profound observation because, it happens every single day. We imagine we need endless hot water because the brochure features a family of 6 and makes it sound amazing.
Yeah, they really sell that lifestyle.
But if you've never actually run out of hot water in your real life, you're paying $4,000 extra to solve a problem you don't even have.
Exactly. You're buying the fantasy of the 10-person family taking simultaneous, luxurious showers when the reality is just you and your spouse brushing your teeth and running the dishwasher.
Yep.
If your demands are low, you don't have natural gas, and your budget is tight, just replace the tank with another tank. Save your money.
Absolutely.
But if you have the space, the climate, and you want to slash your utility bills without altering your lifestyle, that heat pump is an incredible piece of modern engineering.
It really is about matching the physics of the machine to the realities of your floor plan.
So wrapping this all up, our goal was to arm you with the knowledge to make a financially sound, customized decision the very next time your water heater fails.
And you're ready for it now.
You really are. You understand the hidden infrastructure costs of tankless, the brilliant heat-moving physics of a heat pump, and the standby waste of a standard tank. You can walk out to your utility room right now, look at your garage space, check your gas lines, honestly assess your family's water usage, and know exactly what to tell the plumber when they show up.
If we connect this to the bigger picture, this entire conversation raises an important question about how our homes are evolving.
How so?
Well, for decades, our appliances were completely passive objects. A water heater or a furnace was just a dumb metal box sitting in a dark closet, quietly doing its job, isolated from the rest of the house.
Just burning energy.
Right. But with the rise of technology like heat pump water heaters, devices that actively cool and dehumidify the ambient air around them to function, our appliances are no longer passive.
Oh, wow.
They are actively participating in and altering the microclimates of our homes.
It completely flips the script. You stop looking at your house as a collection of isolated boxes holding equipment and start seeing it as a living machine. We are moving toward a reality where utility rooms aren't just storage spaces, but interconnected ecosystems where the byproduct of one machine, like the cold exhaust of a water heater, is purposefully captured to cool a workspace or a pantry.
We are turning the house into an integrated machine where nothing is wasted.
So, as you walk around your home today, look at the spaces where your appliances live. Ask yourself, are these machines fighting each other, dumping heat where it isn't wanted and stealing cool air from where it is? Or are they working together as an ecosystem? Because the next time you step into a freezing cold shower, the answer to that question is going to dictate exactly what you do next. You won't be paying twice, and you won't be shivering in the dark.